Welcome to another sunny and hot and pigeonless day in Thailand. I put my little bird scaring machine into a box and it's doing its job beautifully. So I want to introduce you to yet another little mini prototype project that I've been working on. Like I need another one of those. So let's just jump over here and I'll give you a sneak peek at what I'm playing with. Please feed the YouTube algorithm by giving the video a like. If you want to see more like this, click subscribe and ring the bell to be notified of new videos. If you want to chip in on my expenses, I now have Patreon and YouTube memberships. I want to take a minute and talk about my new sponsor, Summit Electronics. Well, it's actually much more like a partnership. When I went in search of companies to manufacture my EV fuel gauge board, Summit was one of the only ones who replied. And on top of that, they invited me to come to their factory in Bangkok for a full unrestricted tour. Folks, this is the kind of support you want when you're a little guy like me looking to make the jump into production quantity circuit board assembly. Kun Pornrawi met me at the entrance and walked me through their entire factory, showing me everything from incoming inspection to parts inventory, the 14 surface mount part assembly lines and the 10 through-hole part assembly lines, through to the 3-phase quality assurance process. Knowing what I know about the circuit board industry from 40 years of being on the customer side, I came away very impressed. So if you're in the market for simple to complex boards, low to high quantity circuit board assembly and test, you owe it to yourself to contact Summit and join this list of name brand customers. Links are in the description below. So back in my apartment in Barcelona, the windows I have that open up have a blind system literally installed into the window frame. And the blinds go up and down to block the sun or for privacy, and they're controlled by a big hand crank. And boy, am I tired of cranking those things every morning and then back down again at night or whatever. And my apartment has a total of 6 of these. And so I thought, okay, I'm a geek. I can figure out a way to throw some technology at this problem. So what do I need? What are my requirements for this project? Well, I need something that can automatically turn that hand crank for me under some sort of control. I need it to go up and down fairly quickly because I don't want to wait 3 hours for the thing to get into position. I want to be able to control it manually, hopefully with a switch, and I want to be able to control it through some sort of computer interface. So the key to this is clearly some kind of a motor. A motor turns a shaft, and I can connect the shaft to the hand crank, and by spinning the motor, it spins the hand crank, which moves the blind up and down. There's kind of, multiple kinds of motors in the world. You got a motor in your gas car, you got a motor in your electric car, you've got a motor in your washing machine, but those are all too big and too powerful. I don't need anything like that. And then I also need something that I can control quite precisely to make sure that I don't blast past the end of the crank and damage the machinery built into the blind, either too high or too low. So lucky for me, there's a thing called a stepper motor, which exactly fulfills my purpose. Now, a stepper motor, as the name implies, is controlled by the step. You can tell the motor, make one step, and it'll do one step and stop. And the steps are repeatable and very, very precise. I might need a bajillion steps to get the blind up and down, but that's okay. My software and the computer and the motor don't care. They just do what I tell them to do. Now, luckily in the world, we have a lot of examples of running stepper motors, and that's in the form of 3D printers. If you want to understand stepper motors and 3D printers at a more interesting and lower level that I'm going to talk about, go ahead and go to all3dp.com and you can read everything you would possibly want to understand there. Okay, let's skip down and take a look at what they actually look like. There are two sizes in general. The NEMA 23, which is a 2.3 by 2.3 inch frame, and NEMA 17 is a 1.7 by 1.7. Now, clearly, this one's got a bit more grunt to it than this, and the grunt comes in terms of torque. And torque is the amount of force that you can apply to rotate something. So this force translates into rotation, and you're going to get more torque out of the big one than the little one. And as you can see, there's quite a number of different models. Generally, the taller they are, the more torque. These little pancake guys are good for tight spaces where you don't need a lot of torque, but these ones are good for massive torque where space is not an issue. And if we look inside a stepper motor, you can see there's the shaft with the rotor part that rotates, hence the name, and the stator, which is stationary, hence the name. Now there are 4 control wires coming in. These control wires are used to energize little magnets in certain places, and depending on how you energize the 2 pairs of magnets that are controlled, you can make the shaft turn in steps. And that's how the magic happens. Now, you can't just hook a stepper motor up to a little microcontroller like an ESP32 because it just doesn't have the amount of power necessary to drive these 2 pairs of magnets. You need what's called a driver board. And the driver board is this little thing right here, and it has a driver chip on it, which is underneath this little metal heatsink. The driver board acts as the interface between the computer and the motor. So the computer sends control signals to the driver board, and those signals are used to drive the coils of the magnets. Now, generally what you do is you tell the driver board, okay, enable yourself, and then step, and then disable yourself. And the motor goes boop, and it changes by 1 step. You can also tell the driver board to go forwards and backwards, and the direction pin, and that will make the stepper motor go this way or go this way. You can also put the driver motor to sleep, which is very important from a power conservation standpoint. If you're trying to drive this with batteries, which is not going to work, but we always want to try and conserve power. When the board is not in sleep mode, it will hold the magnets energized, which will stop the shaft from turning on its own. But if you just want to set the position and then let the motor go to sleep, then you would activate the sleep pin. Another factor comes into play with how big is a step. Standard NEMA motors are 200 steps makes 1 full rotation. So they're, I think, 1.8 degrees per step. But these modern controller boards are so smart, they can do what's called microstepping. And a microstep is a portion smaller than a step. 1/2, 1/4, 1/8, 1/16. Some go to 1/64, 128th, or a 256th of a step. So 200 times 256 is a really big number, and you can get insanely fine control of stepping the motor around. That's good for a 3D printer where you want very, very, very precise control. Luckily for me, I don't need that. I want the biggest steps I can get because I want to spin this thing 20 or 30 times to make the blind go up and down. So I'm going to pretty much turn microstepping off. And here's a general picture of how we connect our little microcontroller board to the driver board to the motor. And these are all very well documented. Now, from a power standpoint, you're going to need 3.3 to 5 volts to power up your Arduino or your ESP32. You're also going to need to send 3.3 to 5 volts to actually power the chip, but you will need 12 volts to come in and power the magnets of the motor. And the driver chip actually takes in 12 volts and it sends it out as necessary through the 4 wires that control the stepper motor. You can imagine this thing's going to get really hot, pumping 1 or 2 amps at 12 volts through this circuit path. So you always want to make sure you've got sufficient cooling and you've got your heat sink stuck to the top of this chip. Now, last October when I was in Tokyo, I went to the Akihabara electronics neighborhood, and planning ahead, I bought the 3 different models of stepper motor controller they had in stock, plus a 12-volt stepper motor. So the 3 different ones, this is an A4988 chip, and they all come in these little tiny boards with little header pins, and you just snap them into the control board of your 3D printer. This is $5.81. The DRV8434 was $9.13. And the gracefully named TB67S249FTG was $24.07. And the pinout I checked is mostly the same, but maybe a little bit different. And I do know that the software is a lot or slightly different. So pretty much you have to pick a driver chip and then move forward with your project. They're not really, to my understanding, they're not really pin for pin software replaceable. You pull this one out and you plug that one in. Now, doing some research, I found out that the A4988 is one of the most widely used chips on the market. And I found this is the product listing for this chip that I bought. So I learned a lot about the chip from here, including the specifications and other things for it. Then what I also found, I'll pop over to this screen, is that SparkFun, who is a big supplier of little fun electronics parts for people like me, they have a board called the Big Easy Motor Driver with that same chip. So that means any software that runs on their board is going to run on this guy. Now their pinout is quite a bit different from this, but I can handle putting the wires in the right place. And the cool thing is, there's a ton of sample code that goes along with this product and a great description of how you wire up the pins, what the pins functionality is. This is that stepping business that I was talking about. I'm just going to go full step, so I want these 3 pins all pulled low. And then it's got the wiring diagrams and some sample code. So I leveraged all this code and put it into Platform.io, installed it into my little ESP32 board, wired up all the pins, and let's take a look and see how that turned out. Now, one last thing about stepper motor controller boards is they are very delicate, and I found out this the hard way. Never play with the wires connected to the stepper motor driver board with the power plugged into 12 volts, or it will silently stop working. No magic smoke, it just stops spinning the controller, and then you don't know if you made a wiring mistake or a software mistake. So what I recommend is buy a bunch of these during your testing and development. I bought a batch of 10 from Bangkok for 89 cents each, and compare that to the prices of the ones I bought in Tokyo. So at that point, these are disposable. We'll see if they have the lifespan and the full suite of features. It still does have the A4988 chip on it. It is pin compatible, and I popped it in and the motor spins perfectly. So just be careful of your motor driver board. The other critical thing that you need to remember, and let me see if I can focus on that, is right here. There is an electrolytic capacitor. Let me do a bit of a zoom thing. Yes, there it is. This, where's my finger? This electrolytic capacitor goes across the 12-volt input power supply to the board. You absolutely need this or the board will not survive its first power on. Again, another critical component. But once you understand all these little things, everything works out quite nicely. Okay, here we are in my code. And as usual, I've documented everything. I've got the motor here, the 4 wire colors, the documentation from SparkFun on this motor. I've got 3 options for stepper drivers, as I just showed you, and more detail on the A4988 and what pins to connect to which color wires, the power supplies needed. And then here are the important pins that are in the driver board that we need to connect to, including the Microstepping, the enable pin, reset sleep, the step pin that actually controls it, the direction, power, and the 4 wires that drive the motor. And we're going to talk about this other stuff in a moment. And so here's the code. I've defined pin numbers from my ESP32 board, and I pretty much copied in all of the SparkFun code. So to step forward, what you do is you pull the enable pin low, which enables the motor controller. Then you set the direction pin low, which means go forward. On the step pin, you go high and then low, and that triggers 1 step in the forward direction. To go in reverse, we pull the direction pin high and then we step high and low. Microstep mode, we start playing with different values on the MS1, 2, and 3, and then perform a step. Then this spins forwards, then it spins backwards, and then this is the prompt. It's not a very smart prompting system, but we set all the pins as required by normal Arduino. We set them for inputs and outputs. Then this is the loop. So let's go ahead and run this. And I'm showing the motor and everything over here. And when I click number 1, this should spin it in the forward direction. If I type number 2, this should spin it in the reverse direction. If I do 3, this will go into microstep mode, doing 1/8 of a step at a time. You can see how slowly it moves because it's commanding the motor to do 8 separate steps for 1 normal step. And then number 4 simply goes forwards and backwards. There's the forward, there's the backwards. And it'll do this till the end of time. So this pretty much shows the SparkFun code working. My ESP32 is talking to the motor controller is talking to the motor, and everything is cool. This is a very good first step, but now let's go to the next step. Okay, I added a little bit of customization which goes towards my actual use of this project. I want to physically have an up and down button mounted in the box that connects to the hand crank so that you can walk up and manually raise and lower the blind. So I added an up button and a down button pin, pin 23 and pin 25. And then I changed the input function at the bottom to prompt for the button and read the button. So let's go ahead and see what happens. Now, if I push the 1 button, that's down, and it'll just spin down until I stop it. And then the 2 button is for up, and it'll just spin like that till I stop it. So now I have manual control of it too, which is good. But the next one Getting it to respond to computer control is a little more involved, and it actually means we scrap all the software that I've been using up to this point. Now that I've got all this code running on the ESP32, driving the motor controller, I can spin it forwards, backwards, I can change the stepping rate. Now I want to link that to be able to control it remotely through some piece of software. Now, my primary target is this thing called Home Assistant, and it is an open source project that lets you control all kinds of devices that you would generally find in your house, but now they're smart devices or Internet of Things devices. And as you can see, I've got lights, I've got my air conditioning systems, I've got a fan, I got my TV, my Christmas lights even turn on and off through this system. So I want to find a way to get my code talking to Home Assistant. And I searched around a bit and found some tutorials that generally want you to use MQTT as the technology bridge between the ESP32 and Home Assistant. MQTT is a publish and subscribe messaging system where the ESP32 will blast out a status message saying, set the stepper motor to 27. And another piece of software is registered and listening for those messages, sees the request come through, and then performs the action. This is what I would consider a low-level, self-coding solution to my problem. But have I got something for you? There is a thing called ESPHome, and it is designed to bridge the device and the Home Assistant platform for many, many, many kinds of devices that it understands. And I'll just scroll through the list here. You can see these are all the devices that already have components that understand how to run on an ESP32 or an ESP8266 or the Raspberry Pi chip and a couple of other ones. And they are directly controllable via Home Assistant with no programming. And that's the cool thing, is you don't have to have a master's in embedded software to understand how to get Home Assistant talking to the new light bulb you just bought, or if you want it to do fun things. The way this works is you find the device that you're looking for, and if I go down here, they literally have one for stepper motors, which I think is, no, that's controlling an LED. I'll show you that in a minute. Here's the stepper component, and it talks about all the things that ESPHome's stepper component knows how to do to drive a stepper motor. It'll say what's the maximum speed, how fast should it accelerate, how fast should it decelerate, and then how to go about telling it to perform a step. And the way you do this is not with actual executing code. You use this kind of a description format, and ESPHome will build firmware that you upload to your board that uses this as a template for what you want it to do. So I'm saying, for the example, okay, we're going to have a stepper component in my solution. It's running the A4988 chip, which totally coincidentally is the one that I chose for my project, so I'm super thrilled that I don't have to start from scratch with another chip. You then describe which pins on the ESP32 are connected for the step function and the direction function and the sleep function, and your maximum speed and acceleration and deceleration values. And that's pretty much all you have to do. Then you click a button that says, build this configuration. ESPHome will generate a firmware that you then install onto your board. And then you can very, very easily update it over Wi-Fi. You only need to update it or install it with a cable once. And that is super helpful for Internet of Things devices that you have installed all over your house. it would be great to be able to update them over the Wi-Fi without having to take a laptop and somehow plug in a cable to get some sort of updated functionality included. So the ESPHome stepper component talks to the A4988 chip and the ULN2003 chip. Now the primary way you tell it to step is you say, the stepper component set my target to 250. And as soon as that's executed, the stepper motor will set itself to the 250th step position. Now, there's a couple of things. One is an absolute position where the stepper motor will just spin to get to 250 steps, or a relative, sorry, I may have that backwards. The relative one, it will just step 250 steps. In absolute mode, the stepper knows where it is. Say it's on step 175. If you tell it to go to 250, it will only go 75 steps to take it to the 250 position. So you have the flexibility of absolute positioning or relative positioning. You can also have it report back where it is because the component remembers its own state. You can set the speed, you can set the acceleration, and you literally just say, I want 250 steps per second with the exponential notation. So that means that it will accelerate at 250 steps per second until it comes to full speed, and then it will just step at speed, and it will decelerate with whatever rate you want. And that's really cool because you don't want the stepper motor just slamming whatever device it's connected to. You want it to gently get up to speed, just like, things in nature. You don't want to be slamming them into position. Now, there's this other thing which comes into play with Home Assistant, and this is where the integration is great. What you do is you declare your stepper, right, with all the other things and the pins. Then you tell Home Assistant, I want to have a number on my dashboard, and I want it to go from -100 to 100. I want to step it by 1. And that will give you a control on the Home Assistant desktop where you can click up and down. Then, when the user clicks, the action that occurs is you tell the stepper to set target to the value that the user just selected using this lambda function. You don't need to worry about that. You just type it in and it works. So that's cool. So this is the solution I will be moving forward to. But first, we're going to dip our toes in, and we're going to light up the LED on my little board, my ESP32 board, and we'll control it from Home Assistant. And you tell it which pin you want to control the LED, what you want to name it, and the fact that it can be a mono LED, like it just lights up red, or you could have one that has full LED control. But we're just going to go with the little red LED on the board for now. So let's jump over and see how that all works. Now, I'm not going to give a tutorial on ESPHome because it's beyond the scope of what I want to show you here. And there are some great tutorials out there on the net that I found and followed, and it's just easy peasy. But the quick thing is you obviously have Home Assistant installed and running, and you know how to do that. You then go to Settings, Integrations. You add the integration called ESPHome. Once that's installed, you get a new menu item on the left called ESPHome Builder. Click down here, you create a new device. And this is the one I've been working with right here. So I can edit this device, and it's simply a text file in YAML format. That stands for Yet Another Markup Language. But it's basically a series of keywords and colons and values and parameters. You don't have to understand this. ESPHome builds a lot of this for you. Then you just go in and change what you want. Like you give it a technical name, and then you give it a friendly name. You tell it what kind of board you're running. If you want the onboard web server to run, you tell it what port you want, and I'll show you how that works. There's some encryption stuff that happens automatically. You tell it how to join your Wi-Fi network. If you want to fix it at an IP address on your network, you do that here. Then, this is what we're interested in. Everything after captive portal, I have put in myself based on the tutorials. So here, these first two is I'm simply controlling the onboard LED. It's the LEDC component on pin 2, which is already soldered in and wired into that board, and it's a monochromatic LED. So then you go in here, you click up and you say save, and you say install. And once you've got your controller or your thing set up, you have a number of different ways you can install this onto your board. The first one you have to do is either plug in here or plug in here, and you can decide which one works best for you. I've already done this once, so that means I can now wirelessly install this update to the board, and you'll see how this progresses. So it's building a giant suite of software, including all the libraries, all the custom code, and the light component that I've told it to pull in here, some networking stuff, how to do an over-the-air update, and how it talks with devices over sockets. It's starting putting in the web server component, the Wi-Fi that's needed, some core ESPHome. Okay, it's successfully built the image. It's compiling some more stuff. So it's building some needed libraries, which are automatically included. You don't have to worry about any of that. It's pulling in the Arduino framework components that basically make the hardware run. It's linking everything together into one single piece of firmware that it will then proceed to upload to the board. Okay, it's compiled everything and it's built the firmware. Now it's connecting over the Wi-Fi, and my board is not connecting to the Wi-Fi. So let me fix that and I'll get right back to you. All right, my board is not responding on the Wi-Fi, so I'm going to install it over the cable. And we're going to do this. It's preparing the download. And this is not clear at all from the screen, but when this is done preparing, you have to download the firmware file that it just created somewhere on your local machine. And I've already gone through this. So then you click Open ESPHome Web, you click Connect, you connect to the COM port your board is wired to, and then you click Install. You choose the file that you just downloaded, and you click Install. Now this is going to take a while, so I'll zoom through this. And we're done. So we close this out. The ESPHome firmware is now installed on the board, and all we have to do is go back into Home Assistant and make a button for it. So let's close that out, close that out. In our overview of Home Assistant, I have already created a button, but let's go and see what you need to do. If we edit this little one, you find the entity somewhere in, there it is. So you need to find the entity that ESPHome created for you. It is a light control with the symbolic name that you gave it, followed by the name of the actual entity. So once you have that, you save that, and it becomes part of your desktop. Now let's go ahead, and I will click this button, and we'll see what happens to the LED on the board. Click, on, off, on, off. And as you can see, we've got a little blinking blue LED, but it goes on and very quickly off. I don't know if that's my problem, or it's something I don't understand enough about ESPHome's LED control. But we're going to call it a day. I'm happy that I can control things on the ESP32 board from the Home Assistant console. Now, let's jump over and see how we control the stepper motor. Okay, now that we've got our LED kind of blinking on and off, let's see how we can control the stepper with the new stepper component. So go into Builder, Edit, and we'll scroll down past the LED. This is the section of code that does what I need it to do. So the key part here is the stepper control. We're running the 84A4988 chip. We're calling it Window Blind Controller Stepper. You got to make sure these IDs match. Like this one has to match that one. So be careful of what you type. The step pin is connected to pin 21. The direction pin is connected to pin 22. I want it to go a maximum of 250, and I want to accelerate and decelerate gently. And that's all you need to do. No code required. That controls the stepper motor. Now, to make the link with Home Assistant's desktop, you need this number control. And what it is it puts a thing on there where you can click up and down, and this number, when the number changes, it then drives the stepper control. So we say number, we want to go from 0 to 2000, this is just random, I want to step by 1. When the user clicks on number, the action then calls set target on the stepper. Remember, set target is the one that says how many steps to go. And the ID is the one we just defined. And the target of the action is this funny lambda syntax, which basically says, take the number that the user just indicated and send it to the set target of the stepper. Then the stepper control will drive the direction and set step pins to make everything happen. So when we're done with that, we save it, we X out, we can install it, and this time we can install it wirelessly because I know the board is now connected to my Wi-Fi network, so this should go cleanly. It's going to do the standard build like it did before, so I'll skip forward on this a bit. Oh, it knew I didn't change any code, so it is literally updating it over the Wi-Fi, and the board is now running my my system. So let's and here's the debug output from the board. It's connecting to the Wi-Fi on 137 like I wanted, and everything looks good. Now, to get rid of this dialog box, you click stop. You don't click cancel or close. It's a weird name to put here, but don't be afraid. Just click stop. We'll come back over to the overview. And in addition, let me start my camera to watch the board. In addition to the LED, which you can see me go click, 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 I now have this number control. I can type in a number here directly, or I can just click these little up and down buttons. And when I click up, it's driving the stepper motor. We didn't write any code. And if I click down, it's driving the stepper motor in the other direction. And notice I hit 0, it won't let me go below 0. But I can also type in a fun number like 500 and hit enter. Now, did you see that? It made 500 steps, but it did it using the acceleration and the deceleration values. Now watch what happens as it accelerates, goes to a constant speed, and then decelerates. That is just undescribably great. Now, so with Home Assistant, with no code, we typed in a few weird pieces of text following the tutorials. I can now control the LED, and I can now control my stepper motor. I would like to have a slider control here where I can slide it back and forth, which would then make the motor go to the position that I indicate. And the great thing is we can do that. Built into the board at 137 is a web server. and you can see it here, I can directly control the LED, click, 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 and we can see the messages that are going back and forth between ESPHome and the board. And I can also run this slider. When I let go, it drives the stepper motor to that position. We just did 1,000 steps. Now we're going to go to 2,000 steps. And this is absolute right now, not relative. If I go down to 0, it's going to go backwards 2,000 steps. So this is exactly what I want, this kind of a slider control, but on the Home Assistant desktop. And as you can see, ESPHome knows the devices that you've defined, and it gives you a way to control them, which is pretty cool. Okay, it took me quite a lot of effort to work out how to get a slider to control the stepper motor. Turns out we have to add one more thing to ESPHome. Then we add an automation, and then we have access to this stepper control. So let's go take a look and see how that all turned out. Now you have to excuse, I had to basically rewrite all of this to match an example that I found on the web. It was actually one of the AIs gave me the correct, full end-to-end correct example the first time. I was looking in ESPHome and Home Assistant examples, instructions, user forums. I couldn't get anything that worked. Then I just asked one of the AIs and bam, it just gave me the entire thing. But I had to redo all the code. So this is the ESPHome. We saw all this before. This is basically exactly the same format we had before, but with some different names. The one thing I did have to add is this part in the service. And the service is basically a thing that says set the stepper position. It holds that value, that incoming value, as an integer. When this service gets called from something outside, it calls the stepper motor set target method with the value that has been passed in. And we saw this lambda thing before. So you need to add this one little section, and you need to make sure that these little tokens that you're using are exactly the right thing, because if they're not, this will not work. And Home Assistant and ESPHome, they create controls by concatenating different parts of these symbols, and you just got to work it out. I haven't found anything that tells me how to go about building the proper name to be used somewhere else based on these different tokens. And it actually uses this name in part of it and some other things. So just watch out for how you name things and make sure that it works across all the things you're trying to do. So that's ESPHome. You flash this to your board. Fine. Now let's go in and we'll take a look at the automation file. Down at the bottom here, we have to add this section in the automations.yaml file up here. What this does is it creates an entity called stepper position, which is essentially the function call on a thing called an input number. And an input number is an ESPHome control which you can attach to a slider in the user interface. How they went from slider control to input number, I have no idea, but this is what you have to do. So in the automation, this will update the stepper motor position based on a slider value from the user interface. And you've got to have all this trigger business set up. You have to declare your entity ID name properly. You have to call your service properly. And this is where that comes in what I was talking about. The service I need to call in ESPHome is the stepper device set stepper position. And all those things get concatenated with an underscore between them. There's nothing I hate more than magic names of things that have to match between different files. If the compiler can't find it and make sure your syntax is correct, I hate it. Anyway, so when the user updates the slider, it will fire this service and pass it this unimaginably ununderstandable string. And I thank the AI that I asked because it gave me this entire thing perfectly. Now, the last thing you need to do is design or add a component on your user interface, and we'll take a look and see what that is. You have to go in, you have to edit your control. We come down here, our stepper position is, and this is something I also hate, that's that input number dot stepper position that we defined in the automation. So the automation creates an entity, and your user interface only talks to entities in Home Assistant. So we'll select that, we will save that, we will finish with our thing, and let me set up the camera, and we will be able to come down here and slide the slider and watch what the stepper motor does. So we are now controlling the stepper motor with the slider, and this is absolute values. This is going from 0 at the bottom, essentially, to 2000 at the top, and the motor will position itself exactly where you tell it. Now, my little stepper control is still active, and if I put this down to 913, I can change this number to 914, and it moved 1. I can change it to 920, and it moved a little bit. I can increment it like this, and I get 1 move per increment. And then I can do the slider, and it does that. If I decrement from 938 to 937, the motor will go to 937, but it does not update the position of the slider. That's a whole different thing of notifications and state driving things in the user interface, which I haven't bothered to look at yet. So the next thing I want to do is control the motor with these 2 buttons like I had before. And we need to update the ESPHome control to sense the value of the pin on the ESP32. So let's take a look at that. Welcome back to the last and final segment of this video of trying to get the stepper motor to spin. And we're going to add back the up and down button control, but within Home Assistant using the facilities of ESPHome. Now, this was hard. You remember how easy it was to connect up the LED and the slider? Reading the state of that button and driving the stepper motor dropped us into a well of badly documented features and non-trivial code and thinking about how to do this. So, just to prove it works, let's spin our up button. And there it goes. And it stops. Now, I haven't even implemented the down button yet to keep things simple, but the up button works, and you can see that it actually moves the slider in conjunction with the button, which is good, because that helps keeps things consistently between the button and the slider on the user interface and the position of the blind. So, let's go ahead and see what this took. Now, I tried to start doing this myself by searching for examples, came up short. Then I used Gemini AI, right? And it gave me some good examples, but it just didn't work. And I was even getting syntax errors in what the code examples it was giving me. So I changed over to ChatGPT, and on one of the function calls where the number value, Gemini said, just say number.set. But ChatGPT said, no, it's number.set_value, and boom, it started working. So Gemini swore blind that it was telling me the right thing, and I had to go back and tell it that it was wrong. So I used ChatGPT for a while and hit a dead end, and then I jumped over to Grok, and Grok was the best of the bunch. It understood what I was trying to do, and it gave me 4 separate complete examples to use, which didn't work because of the underlying problems with how Home Assistant works, and then we finally got it working on obviously the last one that I tried. So let's take a look and see what it took to make all this happen. Now the key of what's happening here depends on this variable called stepper running. This is in computer science what we call a Boolean. It's a variable that instead of having a 1 to 10, it's either true or false, or logically on or off. So what we're basically trying to do is to do 2 things at the same time within Home Assistant. Home Assistant really wants to be running its user interface, but we also want to be driving the stepper controller and watching for button presses at the same time that the motor's already spinning. This is where we drop into non-trivial functionality. And in computer science, this is something we call multi-threading. Now, there are a number of ways to manage multi-threading where you've got 2 or more things happening at the same time, but they kind of need to know about the state of what each other is doing. And the stepper running variable is our critical state variable that we use to control what's happening. Now, we could have done it with mutual exclusion. We could have done it with semaphores. We could have done it with inter-thread messaging, with IPC. Those are all very computer sciencey ways of figuring this out. But Home Assistant and ESPHome are dead simple. We don't have that kind of sophistication. So we're going with the simplest possible form of a state variable. And the key to making this work is every time we make one step on the motor, we check the state of this variable to decide if we're going to continue. So that's called polling. So one thread will watch the button. When the button changes, it will activate the stepper running button. Then the other thread gets kicked off that actually spins the motor, and every step it checks to see if stepper running is still true. As soon as the button is released, stepper running gets set to false. Therefore, the next check of this variable will cause the stepper motor to stop running. That's the magic sauce that makes all this happen. So let's take a look. Inside the automations file, we have 2 automations. One is called start stepper and one is called stop stepper. So the start stepper gets triggered when the button is pressed, and that is an actual trigger from the up button, the binary sensor. When that changes state to on, then this script gets kicked off, which targets the stepper running value and sets it to on. Then it calls the move stepper up script. Okay, that's all you need to know. Then the stop stepper, that gets triggered when the button is set to off, and that turns the stepper running variable to off. So there's our variable control for managing our threading. It gets turned on here and it gets turned off here. Then we have to go into yet another file called scripts.yaml, and that's the move stepper up script. This is complicated. This is where all the AIs had a problem. And what we're going to do is I'm going to skip over most of this, but basically it's a loop that will run up to 2,000 times, which represents 10 full turns of the motor. When the stepper running is on, we then change the value of the slider and we add 1 to it. This is where we get our synchronization with the slider. Then we take the number in the slider and fire it at the stepper device to tell it to set its position. So this is how we get absolute value of setting the position of the stepper. And this loop will continue until the variable is set to false. And just to take a quick look at the final thing, inside ESPHome controlling the hardware, we have these 2 binary sensor pins. On pin 23 is our up button, and pin 25 is our down button. And to make sure that there's no jitter when the button is making contact, we do a bit of a delay to ensure that the button is fully pressed in the on and the off state. So that basically takes us back to our main control here. I can still run the stepper with the slider sitting on the couch. Or if I actually walk over to the hardware next to the window, and I want to make sure you see what happens to the up button here as I press it. So that gets a checkbox and it says on. I let it go, the checkbox goes away and it sets off. That's because this is also checking the state of the button. Now, I'm going to go back here. Now listen to how this sounds. Sounds pretty smooth and fast. Now listen to what happens when I push the button. Okay, that is what happens when we have to check the state of that variable for every step of the rotation. And now that I have it working, I can tune some of the parameters for how long we wait, how fast the stepper motor goes and all that. But you can tell the added complexity and the actual motor control that happens when we start using hardware to control something in ESPHome. Anyway, so that's going to wrap it up. The next video will be me actually putting all of this into a 3D printed box, attaching it to the wall and the little bar that controls the blind to go up and down, and we'll get to see it in action, and then I'll make 6 more. Before we wrap up, I'd like to thank my Patreons and YouTube members, Peter Bouvier, Puppy, and Craig, for their ongoing support. I see that a whopping 96% of my viewers are not subscribers, so please go ahead and click that subscribe button because it really helps out the YouTube algorithm. Thanks and take care, and I'll see you in the next video.